I'm Anil Kumar, and in this set of videos, we'll discuss modeling with trigonometric functions. It is chapter 6.6 in Nelson, MHF4U. A cosine curve has an amplitude of 3 units and a period of 3 pi radians. The equation of the axis is y equals to 2, and a horizontal shift of pi by 4 radians to the left has been applied. Write the equation of this function. This question will help us to understand the basic transformed trigonometric function equation. Now in this particular case, we want to write in terms of cosine. So in terms of cosine, we can write the function as y equals to a cos of, I prefer to use square brackets here, k times x minus t plus c, right? Now here a is the amplitude, k is the number of cycles in 2 pi radians, d is horizontal shift, and c is the vertical shift. A cosine curve has an amplitude of 3 units, that means a equals to 3. A period of 2 pi. Relation of k with time period is k is 2 pi by t. Now we are given a period of 3 pi, that means k is equals to 2 pi divided by the time period, which is 3 pi radians, right? So 2 pi over 3 pi, that gives us 2 over 3. So the value of k is 2 over 3 in our particular example. The equation of axis is y equals to 2. C gives you equation of axis, so C is equals to 2. A horizontal shift of pi by 4 radians to the left has been applied. So D is minus, since it is left, minus pi by 4. Write the equation of this function. Now in this particular case, we are given all the values. Substituting these values, we can write on the equation. So we get our equation as y equals to a is 3 cos of k is 2 over 3 x minus of minus pi by 4, that makes it plus, plus c, which is 2. So that is the required equation. Now let us extend this question and try to sketch this particular function. So I'll show you my technique of sketching sine and cosine curves. And I think if you understand this technique, it's going to be very simple for you to sketch these functions, rather transform trigonometric functions, very easily. Now I normally sketch them in 2 parts. First, I would like to sketch this function without horizontal translation and then perform horizontal translation to get the final answer, right? Now as you see, amplitude is 3 and vertically this function has been moved 2 units up. So what we can do here is that we can make our axis. So most of the graph is above, so let me draw a line here, leaving more room on the top. Now axis is 2 units, so let us say this is 1 unit for us. This is 2, this is 3, 4 and 5. So axis is 2 units. We draw a dotted line at 2. That is the axis for the graph. Amplitude is 3. That means maximum will go 3 units above this, 1, 2, 3. So small dotted spots, maximum will be somewhere here and minimum will be 3 units down. So this is minus 1 for us. 3 units down. Now it's a cosine function. Cosine function will start from the top always, correct? So what I will do here is I will sketch a cosine function, a light one, right? The idea is that the cosine function will start from the top and kind of go like this and end somewhere on the top, right? So always it starts from the top, right? So I make just one wave here. So that is one wave of cosine function for us. Now this has been drawn deliberately in light color so that you can appreciate that this is actually speaking a part. This is, let me write the equation of this function. This function which I've drawn is y equals to 3 times cos of 2 over 3x plus 2. I'm writing it deliberately in light color. This is not our final answer, correct? Now, here what we know is that the time period is 3 pi. That is to say, let me use another color here. That is to say that it should end at 3 pi, right? So this point is 3 pi. This is 0 for us, right? Midway is the minimum. So that midway should be 3 pi by 2. Let me write here. And this is quarter, right? So this is 3 pi by 4. Do you see that? So it is 3 pi by 4. This becomes 6 pi by 4. And that becomes 9 pi by 4, right? 9 pi by 4. So it's easier. 3 pi by 4, 6 pi by 4 becomes 3 pi by 2, 9 pi by 4, 12 pi by 4 is 3 pi. Perfect. So that is my graph for y equals to 3 cos 2 over 3x plus 2. What we really need is horizontal shift of pi by 4. Now, what is pi by 4? 3 pi by 4 is that much. I'm dividing this into 3 equal parts. So this much is pi by 4. And it moves pi by 4 units left. That means every point moves left by pi by 4. So let me use some different color to indicate that. So from here, instead of starting from x equals to 0, it should start from 3 pi by 4. That is the point, right? So minus pi by 4 is the position where it starts. So every point can be translated pi by 4 units to the left. Do you see that? So we'll move all these points pi by 4 units left. Perfect. And if you join them, well, if you do it on the graph paper, you will get a very accurate result. So that becomes the required function y for us. Do you see that? And of course, this we should label y-axis, which is 2. This one is 5. This is each is, we can write 2, 4, 5 is that. Minus 1 is here, right? That's minus 1. And that is of course 2. So the idea is to teach you how to roughly sketch a very accurate graph, correct? So the policy here is apply the horizontal translation at the end. Without that horizontal translation, sketch your graph. Start with x's. Draw lines for maximum and minimum. So you know your range, which in this case is from -1 to 5. That is, you get by adding amplitude and subtracting amplitude from the axis, right? And then make a wave. Wherever it ends, that is one time period. Write it down. Divide this time period into 4 equal parts. Then you have your graph, right? So that is how you should be actually sketching your graph. I hope that helps. Thank you and all the best.